All right, this section is your property of logs rule. So I have paired up the log and exponent rule as we go through these two here. So you've got the exponent rule, you've got the equivalent logarithm rule. So two logs being multiplied inside transitions to addition between the two logs. So two things you could be asked to do. You could be asked to expand or condense these logs. It may rearrange the wording and say write using addition, subtraction, or condense to multiplication, division. All right, so with this one, we're making it bigger because it's already as a single log. So this would go to the natural log of 5. Anytime you have multiplication inside a log, that translates to addition between two separate logs. So we would do natural log of 5 plus the natural log of 3. So instead of multiplying inside of the log, we will add between two logs. Next one. Natural log of 2x. Remember, 2x is 2 times x. So we would change to the natural log of 2 plus the natural log of x. All right, C. So they work with between two things. They also work between 3 of them. So condensing just means change it back to multiplication, and we'll get to division in a minute. But it works the same. Even if you have multiple plus signs, you would have multiple multiplication signs. So this is your common log, so just log, and then we go left to right, 4 times 2 times x. So because we had 2 addition signs, that translated to 2 multiplication signs. We would then go a step further here because 4 and 2 can be multiplied. We would want to rewrite that as log 8x. And you could do 8 times x, but 8x is fine. Right. Next rule. So here's your exponents. This is the typical exponent version you're used to seeing. But negative exponents I also like to include in here as well. So those are kind of your 2 exponent rules that go along with this. For the logs, division translates to subtraction. So multiplication inside translates to addition outside. Division inside translates to subtraction outside. All right, so you rewrite using addition and or subtraction versus rewrite using multiplication and or division. So addition, subtractions when you're making it bigger. So it would be natural log of 4 minus natural log of 3. Second one. So you got to be careful in here. We have multiple things. So we have to get everything separated. So anytime you're rewriting using multiplication and division, the easiest way to remember is anything in the numerator being multiplied gets a plus sign. Anything in the denominator being multiplied gets a minus sign, because that's the only way to make it go to the bottom. So this would be natural log of 2 plus, because we're still in the numerator, natural log of x minus, because now we're moving to the bottom, natural log of 5. Next one. So condense or rewrite using multiplication and or division. If it's being added, it goes in the top. If it's being subtracted, it goes in the bottom. So I'm going to write this one below so I can kind of keep it all lined up. So I got my log. I see addition and subtraction, so immediately I'm going to draw a bar. All right, left to right, the 3 is at the front, so it's positive, so it's going up, times, because I hit a plus sign, the 2 also goes up. Then we hit a minus sign, so the x goes in the bottom. And then we hit another minus sign, so the 4 also goes to the bottom. So we get here. Let me scooch this over. Once it's down, then you may need to simplify, so you got to simplify everything as much as possible. So that would be, I'm going to go this way so I don't run into the edge of the paper. Log of 3 times 2 is 6 over 4x, and then you've got to get that 6 over 4 reduced. So log of that is 3 over 2x. Next, your power rule. So this is your exponent version. Remember, be careful. We don't want to get them mixed up. This is a parenthesis separation. So they get multiplied up in the exponent. For logarithms, that exponent gets moved to the front and it gets multiplied. All right. So here the exponent is on the back. So we are wanting to move it to the front. 3 times natural log of 2. For B, be careful with this one. We often get a problem like this mixed up with the one I just drew parentheses around. There are no parentheses here, so that means that multiplication needs to come first. So I'm going to do this one in 2 steps. Natural log of 3. I hit multiplication, so plus natural log of x squared. Then once you're comfortable enough, if you want, you could move that all in one step. But you want to make sure you understand that 2 does not go to the front first. This is the natural log of 3 plus 2 times the natural log of x. So be careful with that. Oh, look at that. There it is. C versus this one. So with this one, the 2 is going to go to everything. So there's a couple of different ways you could write this. You could move it to the front right away. So let's go 2 to the front. So we're going to get 2 times, also going to do this one in more than one step, 3x. So now that 2 is sitting on the front before you're going to change over to the addition, which means the 2 belongs both in front of the log with the 3 and in front of the log with the x. So make sure you get both of those in there. So another way you might see this one written, just in case, so just be careful with the online assignments, is that 2, because it did go on that 3, you could technically put it back here. So then it's the natural log of 3 squared. And then 3 squared is 9, so ln of 9 plus 2 ln x. So one of these two is perfectly fine. So just kind of double check both of those. All right, next, all right, going the other way. So now we got everything rolled into here. We got addition, subtraction, we got multiplication, we got it all. So when you're going back to changing it over to multiplication and division and powers, exponents go back first. So this 2's got to get put back. Second 2 also put back, and the 4. So exponents go back to where they came from first. So this would be log of x squared plus log of 3 squared minus log of y to the 4th. Then I can write my log once. Anything added, top. Anything subtracted, bottom. So the x squared is on the top, plus, so times, 3 squared, and then minus, so bottom, y4. Then as far as rewriting goes, 3 squared does look better as 9, so let's rewrite it as 9. And then we have the x squared, and then the y to the 4th on the bottom. Right. Next set is your basic properties of logs, so be careful through these. We often evaluate logs. Important thing to understand, the log of 1 is 0. I don't care what this base is. If you're taking the log of 1, the answer is 0. Similarly, if the base and what's in the log match, that is going to be 1. And then the last one's got 2 versions. So it's got the version, it's where the base and what's in the log match. The answer is just the exponent, or it's got the kind of reverse of that. The base and the log are still the same. It's just the log is up in the exponent. So the answer is what's inside that log. All right, so running through these properties. So evaluate or simplify as much as you can. So log base 3 of 3. Remember, a log is just an exponent. 3 to what power is itself? 3 to what power is itself? Well, the only way I can do it is raise it to the 1 power. When the base of the log and the number in the log match, the answer is the exponent. And remember, this exponent on this 3 is a 1. So the answer is 1. Second one. The base of the log is 2. The number inside the log is also 2. So the answer is the exponent, which is x. I don't know why it says a, that should say b. A sub 2. All right, next one should be c. I guess I didn't get my letters changed here. The log of 1, this is your common logs, so there is a 10 there, but again, it does not matter. The log of 1 is 0. The log of 1 is 0. I don't care if this is a 10, if this is a 5, if this is a 1/3. The log of 1 is always 0. And then next one, natural log of e. Remember, natural log is base e. If it helps, put an e there. The base of the log is e. What's in the log is also e. So the answer is the exponent, and the exponent's a 1. Next one. The log is up in the exponent this time, but the base of the exponent is 5. The base of the log is also 5, so the answer is what is inside of the log, 7x. I can get them all, maybe. There we go. All right, common mistakes with logs, so just be careful. Addition, subtraction, inside does not separate. There's nothing you can do to expand that log. This one here, division between separate ones, is not division inside of a log. And then the last one, just be careful with that n. We went over an example similar to this one. That n can only come to the front if it's like this in a set of parentheses. So just common errors, so be really, really careful of those. All right, using properties of logs to expand, it might say rewrite using addition, subtraction. All right, so when we're expanding, we separate all multiplication and all division, and we move all exponents to the front. So I'm just going to kind of go left to right. So first thing I notice I run into is an x to the 3rd. I'm going to go ahead and move that 3 to the front, which means it's just going to be the log of x. I hit a multiplication symbol, so I'm going to put a plus sign. Next thing we run into is y squared. So I'm going to move the 2 to the front. I'm going to put a log, and it's just y. We hit multiplication again. So I'm going to put another plus sign, but this time the exponent on z is a 1. We don't ever write a 1 in. There's just not going to be a number in the front. So I'm going to do log again, this time of z. And that's it. All right, next. We got a lot going on in here. So remember, rewrite using addition and or subtraction, move all exponents to the front. So we not only have to deal with all of this multiplication, but then we got to consider that division bar in the middle. So everything that came out of the top gets added. Everything that comes out of the bottom gets subtracted. Also notice this is a log base 2, so make sure we have a subscript 2 on all of our logs. So left to right across the numerator, first thing we run into is a 5. The exponent on that 5 is a 1, so nothing to move to the front. So just log base 2 of 5. I hit multiplication, so I'm going to put a plus sign. Next thing we run into is x squared. The 2 has to come to the front. Then I put log base 2 of x. I hit another multiplication sign, so another plus sign. This time we're running into y to the 3rd power. 3 has to come to the front. Log base 2 of y. Now we're moving into the denominator. So once you go down to the denominator, you're going to be using minus signs. So I'm going to put minus. We hit 3. Exponent on that 3 is a 1, so nothing to move through the front. So just log base 2 of 3. I hit multiplication in the denominator. Remember, multiplication in the denominator is subtraction. And then it's z to the 1st, so just log base 2 of z. That was long. Let's scooch it over just a little bit so it's not running into the other one. Yeah, we'll do a little separation here. All right, got a square root symbol on there. Okay, so first thing I would do is make sure you get that square root changed to the equivalent exponent of 1/2. So that is ln of y cubed times z all over x to the 5th all to the 1/2 power. So you kind of have some choices on this. If you're going to move this to the front first, so that 1/2, if you're going to move it to the front first, remember, it is also going to the front of every other log you create. So when we separate the multiplication between the y and the z, the 1/2 has to go on the front there. When we separate the division with the x to the 5th, the 1/2 also has to go on the front. So this might be one you want to take more than one step on. So first thing is 1/2. Then I'm going to do ln. I run into y to the 3rd. I'm going to leave it alone right now because I don't want to bring too many numbers out at the same time. We hit multiplication, so I'm going to put a plus sign. Remember, the 1/2 goes to every log we create at this point. So 1/2 ln z. Then we hit a division bar, so I'm going to do minus. But again, we're creating logs, so the 1/2 has to go into the front. I'm about to run out of room. And then it's ln x to the 5th. Then we can move our additional exponents. So the 3's got to go. Any additional exponent you move out is just going to get multiplied by whatever's already there. So if we move the 3 down and multiply, 3 times 1/2 is 3 over 2. ln y. Plus the z is just a 1, so it's just going to stay 1/2. Minus, and then we're going to move the 5 down. 5 times 1/2 is 5/2 ln x. So be careful when you've got an exponent that belongs to everything. Any log you create from it also gets that number out front. Zoom and make them all fit. Maybe it's gonna be tiny. Yeah, a little small, but there it is. Are using properties of logs to condense, simplify if possible. Could say rewrite using multiplication and or division. So we're going back to one log. So first thing I notice is this 3 here. I like to go ahead and clear parentheses first, so I'm going to distribute. Remember, you cannot go inside of a log when we're distributing. That's being multiplied. It's going in front of the log. So I've got natural log of 2x, haven't done anything with it yet, plus 3 times natural log of x minus 3 times natural log of y. Now I can put the individual exponents back, so nothing on the ln of 2x. The 3 is going to go back to the x, and then this 3 is going to go back to the y. So natural log 2x plus natural log x cubed minus natural log y cubed. Once you get your exponents back, then we can do 1 ln. I see pluses and minuses, so I'm going to make a division bar. Anytime it's pluses and minuses, you got stuff on the top and the bottom. So first thing we run into is the 2x. It's positive, so on the top, I hit a plus sign, so times. Moving stuff. I run into x cubed. Then I hit a minus sign, so the y to the 3rd is going on the bottom. So all of that is inside that log. Now, anytime you go down to one log, you do need to simplify if possible. So this is where you may need some of your exponent properties. So the exponent property we need here is, let's say we have x to the 2 times x to the 5. That is x to the 2 plus 5, which is x to the 7. So that is the property we need to use to get this condensed correctly. So what we're combining is these two in the top being multiplied. So we're going to get ln of 2x to the 1 plus 3 is 4 over y cubed. B. Same thing, condensing. First, put your exponents back. So the 3 is going to go back here, and the 1/2 is going to go back here. So we've got log of x minus log x minus 5 to the third plus log x plus 5 to the 1/2. So then what you want to do is you've got to be careful because you have subtraction involved and you have addition involved and you have exponents on them. You've got to remember exponents cannot be distributed along addition or subtraction. So that 3 and that 1/2 are stuck where they're given. So I'm going to go to a single log. I see addition and subtraction, so I know I need a bar. The x is positive, so it's going on the top. The x minus 5 to the third is negative, so it's going on the bottom. Then we have the next one's positive, so times x plus 5 to the 1/2. And there is nothing you can do to clean this up. This is all we can do with it. And it is possible that x plus 5, remember a 1/2 power is just a square root. So if you wanted to write it this way, it is the same thing. But there's really not a reason to, unless you just think it's prettier. I don't. So we're here. I think there was a C. Yeah, that was a rough one. All right, C. Got a lot of stuff going on here. So first things first, numbers back to the exponent. Okay, so 4's going, 4's going, 3's going, 3's going, 2's going, everything's going. All right, so that's going to give us natural log of 2 to the 4th plus natural log x. So here's where we need to be careful. I'm going to do this one in multiple steps just so we can make sure we get our properties right. The 6 was already there, so then we're also putting a 4. And then we have minus natural log of 2 to the third minus the natural log of the y squared's already there, but now we're putting a 3 back. And then lastly, ln x squared. All right, at this point, I would go ahead and clean that up a little bit because if we try to go down to 1 log right now, it's going to look really, really ugly. So the exponent property, we need to deal with that ln of the x to the 6th part and the y to the squared part is one of the properties listed above as well. And that is like x to the 2 and then quantity to the third. That is x to the 2 times 3, which is 6. So in this case, we are multiplying. Another thing I would do is I would probably go ahead and evaluate my numbers because we do want to get them completely reduced. So 2 to the 4th is 16. Second one, natural log of x, it's 6 times 4, so 24, minus ln 2 to the third is 8, minus ln of y 2 times 3, 6, minus ln x squared. Now I would feel comfortable going to a single log. So I see pluses and minuses, so ln and a division bar. And then we play the top bottom game. All right, 16 is positive, goes up. X to the 24th is positive, also goes up. The 8 is negative, goes down. Y to the 6th is negative, goes down. And x squared, also negative, goes down. So we get here. All right, simplifying, we got 2 things to deal with. 1, the numbers, 16 and 8 reduces nicely. 2, I have multiple x's, so then we need yet another exponent property from above. So I'll come off to the side, show you that one. So if I have x to the 5 divided by x to the 2, that is x to the 5 minus 2, which would be x cubed. So we subtract. Also with your exponents, you never want a negative exponent. So say we had x to the 3 on top and then x to the 7 on bottom. Notice on the first one, I moved the 2 up. For this one, you would want to move the 3 down. So we would get 1 over x to the 7 minus 3. So 1 over x to the 4. So we never want negative exponents. So just subtract the smaller one from the bigger one. All right, so with this one, The 16 divides nicely. Oh, why won't you zoom in? There we go. 16 divides nicely by 8, and it is 2. Y to the 6 has nothing to worry about, so I'll put my division bar with y to the 6 on the bottom since there's no other y's. And then for our x's, the 2's smaller, so we're going to move the 2 up and subtract it. 24 minus 2 is 22. And there's our answer. So that was a little rough. It was long. All right, the rest of these are your you try it. So make sure you got your properties down and then feel free to check them with the completed notes in Canvas.